my project was initially supposed to create a drug to diagnose the early onset of Alzheimer's before symptoms start to show. And that was really successful, and I also accidentally discovered it treats the disease at the same time, which is really good news because it wasn't supposed to happen and it did, and nothing exists to treat the disease right now. So if this is validated and carried out in some more tests, this could really be a useful tool. I had to do this at a university lab because my school doesn't have all this fancy equipment, and a 15-year-old with toxic chemicals and expensive equipment isn't really the best or the safest combination of things. So a lot of labs said no. The ones that did say yes said I had to have 6 months health and safety training. I wasn't allowed to touch anything toxic, and I had to be supervised at all times. Other than that, I could do my project, which was good. So I look at a special protein that's there up to a decade before symptoms start to show. This protein is called amyloid beta oligomers. I got an antibody to target this protein, and I also was able to get the antibody to cross the blood-brain barrier, and then to image it I had to create a nanoparticle. That's an animation, so ignore that. I had to create a nanoparticle, and this nanoparticle had 2 ways of being imaged. The one, it fluoresces at a wavelength we can detect externally. The second is also an MRI scan. It shows up as a contrast. Doing some more research, I found out it had therapeutic properties. So the red stuff is the toxic stuff. There's a lot less of the toxic stuff in the treated sample in comparison to the control sample. So we're trying to get the clearance for phase 1 animal trials, and if hopefully that goes well, then we'll progress this even further.